All right, guys. For this chapter, at least part of this chapter, I'm going to start doing recordings for you. We talked about kind of flipping the classroom, and I'm hoping this works well because I'm going to get more questions answered in class. Section 1 in Chapter 11 is on area of polygons. Area, it refers to the number of squares that fit on top of the region. Therefore, it is measured in square units. So if you look down below here on the left, 1 by 1 square represents 1 square unit. And then um, on the right, we talk about rectangle being non-shaded, like on top. That would not be, that'd just be a shape. Whereas below, we're talking about a rectangular region where we can find the area of it. So the non-shaded one on top is kind of like a hole. The one on the bottom is the region we can find the area of. Think of like a carpet in a room. So the area of the shape in the middle, if we were to shade this in, this whole area we're shaded in, there's no complex formula here. We can just count these up. If you count up that whole shaded region, we will get 12 square units. Right, this chapter goes back to using some postulates that we covered earlier this year. Postulate 17 says that the area of a square is the square of the length of a side. So if we look at this picture, um, if we divide this into units, so right now we have 4, 4, 4, and 4. So if all four sides had four little squares long, to find the area of this, we would take 4 and we would square it. 4 squared is 16 square units. And if you count all those little boxes up, there are 16 of them. So the formula we can use for a square, we'd say area of a square equals s squared. In this case, s is the length of the side. And we already know that all four sides in a square are the same. So s is the same all the way around the square. Postulate 18. If two figures are congruent, then they have the same area. And then going down to postulate 19 is the area addition postulate. It's kind of like angle addition postulate, segment addition postulate from earlier this year. The area addition postulate says that the area of a region is the sum of the areas of its non-overlapping regions. So if we look at this picture, P, W, Q, R is a quadrilateral, kind of a weird shaped quadrilateral. But inside of there we have these two triangles. So to find the area of this quadrilateral, there's no special formula, but we could take the area of that red triangle. So it'd be area of WPR plus the area of this green triangle, which would be the area of WRQ. So for weird shapes, we just add up all the areas that are in there. So we can find the area of a triangle, or the red triangle and the green triangle to find the blue quadrilateral. All right, naming parts of a rectangle. I'm going to flip over. The base, this is any side of a rectangle or parallelogram. This term refers to the segment or the length. The altitude is the segment that is perpendicular to the base. So depending on how the shape is flipped, the altitude or base could be on any side of the shape or any part of the shape. And the length of the altitude is called the height. So whenever we're referring to height, we're talking about perpendicular distance, not anything else. So height and altitude go together. If you look at the box to the right, the altitude of this is segment MQ, and the height is the length of MQ, which in this picture is 6 inches. So in each of the examples, we're going to draw in the altitude. If we were to draw the altitude in the one on the left, where you see the base of this rectangle, the altitude would be the perpendicular distance across that rectangle, across that quadrilateral. And this is also called the height. Okay, looking at the second one that's kind of flipped sideways, if the base is along the side, so we trace that base over here, the altitude is the perpendicular distance. So in this case, the height actually runs left to right. So height goes side to side sometimes if we're referring to the base as this side over on the right. Going over to the third one, if the base runs along the bottom, the altitude is our perpendicular height. So here's our base. The altitude is going to be right here. So this is the height. We could also extend the base and could use this as our height. So the height is the perpendicular distance from the base to the other side. So in this third one, it's vertical. And then for the last one, the fourth one, this gets a little tricky. So looking at the base, which is right here, it's kind of slanted this time. The height is going to be the perpendicular distance across. So we draw an altitude across from the base. This is the height. We could also extend this side just like we did last chapter. And this perpendicular distance right here could also be referred to as the height. So the height is perpendicular from the base to the other side. It doesn't have to be up and down. It sometimes is horizontal. Sometimes up and down, and like in the green one, you can see that it goes diagonal across. So height is reference to the base. Theorem 11.1, area of a rectangle. You all probably know this already, but the area of the rectangle is the product. And product means multiplication. The product of the base and the height. So if you look at the picture, area is everything on the inside. If this is a rectangle, we're going to make it look like a rectangle, so make all these right angles. So if the base is this side, the bottom side, we would refer to the height as the perpendicular distance across. So the height is right here. So the area of the rectangle we'll refer to as B times h, or base times height. And if we scroll down to our last example, find the area of the figure. Consecutive sides are perpendicular. What that means, consecutive sides would be the bottom and this side form a right angle. So all consecutive sides form a right angle. To find this area, we're actually going to use postulate 19, area addition postulate, and we're going to break this apart into two separate figures. We could cut two rectangles apart, and I'm going to go this way, up and down. So you break these into two rectangles. Area of a rectangle, remember, is base times height. So we're going to find the area of this blue rectangle on the left. We can find the base and multiply it by the height. So I'll give you a second. Try to think, how would you find the base? Because there's no number down here for the base. You should find out the base equals 13 because 13 plus 4 adds up to 17. So to find the area of the blue rectangle, it's going to be base, which is 13, times the height, which is 15. That's the blue one. And if we switch colors, we need to find the area of this red rectangle. So again, we have to refer to a base and a height. The base of this one we'll go with is 4. Therefore, the height of this red rectangle is going to be 10. So the area is equal to 4 times 10. If we put this all together, the area of this shape is equal to 15 times 13, not 3, plus 4 times 10. And again, this is using area addition postulate. So the area ends up being 195 plus 40. So our final answer, we get 235. And then we have to use units in this chapter. Make sure you label everything. We use centimeters. And remember from the front page that area is always units squared. So it's going to be centimeters squared. Right. And that's all we got for the first section. Hopefully you guys can get access to this on the iPad pretty easy. For homework, I will get that to you in class tomorrow morning. We'll go through all that. Just a little side note, I'm going to tell you this in class tomorrow anyways, but when I do these recordings, I believe you have the option to hit ×2 or ×3 to kind of like speed through it. You can do these notes at your own pace. Just make sure you get them done. As long as you get them done that night, it'll kind of keep you on task because we're just doing notes for homework and we'll do the assignment in class.